This is like a series of event, a roadshow event that happens all around the world, right? So this is the Hong Kong one. If you go on the website, you will also see like a bunch of other locations that's happening. So it's really about celebrating this quite a big occasion for all the L2s. Right, so I will leave it up to our guests to sort of explain, what this Dencun upgrade will do for the developer ecosystem, to all the L2s. So first up, we have Laura from Linea, head of international expansions. So we have a keynote, and then we'll also have other speakers that will talk about like different applications and use cases after this Dencun upgrade. So you can. I'll switch the slides.
Thank you. Oh. Yeah.
Maybe stand in the middle.
Okay.
It's better for the camera.
So thank you very much, everyone. So my name is Laura. I lead the international expansion consensus. And as you know, I think one of the storytelling of Linea is that Linea is part of consensus who also introduced MetaMask, Infura. We are decentralizing Infura. We got staking solutions. We got Ethereum consensus client as well as execution layer clients as well. So like a quick introduction of consensus, by the way. So I won't overuse the time because it's mainly about the ecosystem partners building on Linea that I want to introduce through this meetup for them sharing their understanding as well as their journey working on, build on top of a layer 2 and especially with this most excited things that's going to be happening in the next, I would say 3 weeks. Because like an interesting message that I like to deliver is that, of course, we will have layer 1 Dencun upgrade in the next 24 hours, but that doesn't mean an immediate gas reduction in layer 2. All the layer 2s need to have their own 4844 upgrade. For Linea, we schedule it before end of March. So hopefully by then you will, that will be the time you truly experience it, layer 2 by layer 2, with hopefully over 90% gas cost deduction. For someone who is not very familiar with how rollup going to work, so this is a quick flow virtualizing what is the cost-saving part and why layer 2 matters, or rollup matters for Ethereum. It's not only about lower transaction costs, it's also about higher TPS. Even though there's an interesting debate, say until today, we only see even like around low teens of TPS, even for layer 2. And another message I want to deliver is that by the time we have gas cost deduction on a layer 2, let's say by 90%, theoretically a TPS that's capable to deliver by a layer 2 can be around 300 to up to 600 TPS. So if you do your own calculation with the 90% deduction of the gas cost up to 600 TPS, what kinds of transaction you want to make it happen on chain? That can bring, relatively speaking, lower quality, lower value transaction in your daily business operation on chain, but it doesn't mean everything. Therefore, whoever, I don't know, today sitting in the room considering introducing your own app chain, again, rethink it, even though I know there's a bull market upcoming. Quick update about what's happening in Linea as a tech upgrade happening 1 month ago, right before Dencun, is that we have our alpha version 2 as a tech upgrade. Long story short, there's 2 focus. Focus number 1, we got a proof aggregation. Focus number 2, we got compressed data transactions, data submission. And this is, again, another much better way to virtualize what does that mean. And it also means that with a proof aggregation, with a compressed data submission, gas costs reduced. But if you take one step back, think about what are the gas costs we reduced. This one, the January ZK proof. That one, not gas cost, it's actually the cost that's reflected as a layer 2 gas got reduced through a proof aggregator. It also helped through this data submission compression. And now it comes to what before what 4844 can contribute. Here is the gas cost after our version 2 upgrade. So since 1 month ago, Linea is actually one of the lowest gas cost layer 2 in this industry. But unfortunately, right after that, we have layer 1 gas increase materially. And that's why you may, when you experience it, for example, you do an on-ramp or do a DAX interaction two weeks ago, and you now, especially in the past 3 days, if you want to do something on-chain on a layer 2, you still experience up to $1 to $2, even though the GUI is only like 14 to 16. That's what you experience at the moment. It has nothing to do with layer 2 ask for too much gas. It's mainly because layer 1 gas increase. And yeah, here is what 4844 can contribute. I don't have a tech background. This is the best pictures that I love to simplify what is 4844 provide value add. 4844 is mainly about the layer 1 proof generation verification. And that is actually, again, if we go back to the first slides about how rollup work, that part in terms of verify proof on layer 1 is actually cost people materially for whoever want to make a transaction happens on layer 2. And this is what hopefully we are going to fix in the next 24 hours, and all the layer 2 will follow up in the next months. And by then, hopefully we got 90% gas deduction. Here is the gas cost you're expecting. Again, do your own calculations, 300 to 600 TPS, whether or not there should be an app chain versus a DApp, maximize the ROI for the fund you raised. This is a calculation you need to work with. I think that's all from my end, and I want to pass the rest of the time to our guest speakers.
Right, so next up, we actually have speaker Andy from Mugen Interactive. I hope I'm not butchering the name. So yeah.
So I've heard so many versions, you're the best version so far.
Yeah, so he's gonna talk about the dawn of a new era for gaming.
Okay, great, thanks Kathy. Good evening everyone. Thanks to everyone for taking time. My name is Andy, I'm the co-founder and CEO of Mugen Interactive. We're a Hong Kong-based gaming company, which is literally my office is in Wan Chai, so a few blocks away from here. So, I used to work at Tencent, work at Lightspeed Studios, building like the PUBG, Teamfight Tactics, and Card Rider, NBA. So, building games is something I've been very passionate about. And when I saw an issue working for a corporate, I decided to leave the company and actually start a company, Web3. I don't have slides today, to be honest. So I actually want to tell you 3 stories, very simple stories. On why I think this upgrade will actually change the way that people engage games and people play and get more people to on board and actually play games in Web3. So the first story I'll tell you is back in 2015. That was the time when I just joined Tencent, and one of the things I spoke and then I was telling my boss at that time, he was asking me a really simple question: do you think people actually will pay for games? And my answer to him is like, no, because I think people are too cheap. People have been buying like rip-offs, like copies. You go BitTorrent. Back in the days, you go BitTorrent and buy games all the time, or you get games all the time. Why would people want to play games? And the next thing I know it, I was on a plane to the US talking to an IP partner, which I can't disclose the name, but they're fairly big. They asked the same question as well too. I said, Andy, if we license this IP to you and build a game, how much are you charging per person? I was like, we're not charging per person. We're making it free to play. And then they were like, why do you want to do free to play? And that was actually, when you've actually started looking at how free to play worked, it actually lowered the barrier entry for people to experience games. You don't have to pay for it. You can actually try it out. And actually, if you love the experience, people started paying for it. I did not believe that when I joined Tencent. And then Honor Kings happened, and everything happened as well. And free-to-play became the thing in mobile gaming and actually changed the way people play games, as well as changed the way developers actually launch games. So that was the first lesson I thought was the cost for building games or experiencing games is getting lower and lower. You used to pay $30 just to pay for a game. And when free-to-play came out, you actually pay $0. But the ARPU that you generated is more than that. The ARPU on average for a lot of games today was actually more than $200 per person. So in net, you actually make more money from actually lower the barrier entry. So that was the first story that I want to share with you today, is that I think we're going through a phase where it's similar to how in Web3 today, that we're going through the phase where how mobile games free-to-play actually worked. When the cost actually starts going down, this is when you start getting more users coming in. And I think that's happening in Web3 today on the games that we're seeing that's launching this year as well, where if you actually lower that barrier entry, if you actually make the cost more affordable, you will actually get more users coming in. So that's the first story. Really simple on how I built the first game on free-to-play and how I made that mistake and tell my boss that you're an idiot. I don't think anyone's gonna pay for the game, since that's the same thing my partners told me, and I was wrong. And I stayed there for 5 years afterwards, so that was good. The second story I want to tell Pearson happened in 2020. I think it was 2021 or 2022. It was 10 p.m. at night. I just got off a plane, coming back, and then I got a phone call from my mother. Now, how many of you actually get phone calls from your mother at 10 p.m.? Okay, so if you do, are they usually a good thing or bad thing? So my mother called me at 10 p.m. and I picked up my phone. I was like, "Mom, what's going on?" I was like, "Hey, son, what is step N?" I was like, "Mom, how do you?" My mom is 60-something years, by the way. Just telling you. And I was like, "Mom, how do you know how do you know step N?" I was like, all my friends are actually playing it. They're actually walking around. It looks cool. Can you actually come over and help me set it up? That was the scariest call of my life. And also the best call, actually. I'll tell you why as well. Because I went there, she actually took the effort trying to set up an account using step N, trying to buy Solana, and actually get GMT and everything like that. And she actually enjoyed the experience. So one thing that I actually learned from that was, in fact, building Web3 games does not have to be complicated. If you actually make something straightforward, people will actually come on board. And I think that also goes back to the first lesson I learned. If you lower the barrier entry for anything, making it easy for everyone to come on board, it will happen. So I think this goes back to even though I had the scare of my life, just getting my mother's call at 10 p.m. at night and ask me what is step N and can she use it? That was actually the best call, because it actually gave me more confidence in building the game company that we're gonna launch. I started building 2 years ago, and we're launching 2 games this year. Taking into those inspirations and ideas, and building into the games that we have today. So, first lesson: if you lower the cost, people are cheap. If you lower the cost, if you lower barrier entry, people come in. Second thing, if you make the experience really smooth and well, people will join the crowd. Now, anyone wants to guess what this third story about? Play to earn? No. Okay. Bitcoin all-time high? Which all-time high? It's gone to way too many all-time. No, so this is the story of my own learnings of the past 2 years. When we were building our games, and actually we've been waiting for something like a Dencun upgrade for a long time as well, because I think cost is always a hassle for most people. And trying to understand what gas fee is a hassle for most people today. And if you lower it to the extent that you don't really care about it, then I think that's going to drive in a lot more people. Now, when you actually drive more people in, one, there's frustrations, and one of the things that we see from a lot of people is how do you retain these people? Because the way I see the issue of crypto today, especially people building crypto games today, is that there is no such thing as retention for a lot of these games. If you actually look at a lot of retention rates for games out there today, the first generation GameFi, I will guarantee you the next day retention is like looking at 88%. By day 7 it was 87%. It does not make sense in my head, because it usually would drop. So when we actually built our game, we did see that at the very beginning was really high retention, but what we tried to do actually is to build in game mechanics that changes the way people stay in the game and actually make them consume these tokens. We end up having 56% retention rate by day 7, which I think is much more normalized, and even by day 1, even by next day 86, but dropping down 56% makes a lot more sense for us. We tried different tactics on trying to retain people. We brought in social betting. We brought in prediction ideas. We brought in things that can drive people to talk to each other. We drive the idea of we're trying to do seasons in our games. And we're taking a lot of these learnings from what we build in Web 2 and actually take to Web 3. And I think it's going to be the thing that's going to take people to actually make crypto work, because crypto needs a use case. I've had friends who tell me that for the 10 years they've been looking for something, a use case. If after this cycle there's no use case, they'll leave this whole industry and just go back to some factory they actually own somewhere in China. So what I'm really excited about is if we actually have the formula right, which is if you lower the barrier entry when the cost is low, if you actually make the experience smooth enough, and actually if you find ways to actually for people to stay, then you actually have better crypto prices and actually have better retention, in fact, and actually drive a better user experience overall. So we're launching our 2 games this year, taking these ideas, hopefully it'll work. Thank you.
Thanks, Andy. So next up, we have Joshua from Supra Oracles talking about Oracle use cases for DeFi and GameFi on Linea. I will switch to the slides.
Thank you. Andy, that was great. So I can get a better sense of the audience, how many of you are engineers? VCs? Okay, that's good. No hands up. What about protocol designers or game designers? Okay, so we're talking to mostly engineers. I do want to kind of, expand upon the other 2 conversations. One of them is really related to costs, right? So if Linea is approximately 2 cents per transaction, and the competitor is on the order of 3 cents, that's actually a 50% difference in cost. It's a big leap there, actually, if you think about it. So I do agree that with more cheaper prices, you can do more things, and you can scale. And this is, by the way, I should kind of mention this quickly before I forget. Protocols that are launching on layer 2s, often they are forks of protocols that were on Ethereum layer 1, right? And the main oracle on Ethereum layer 1 was, of course, Chainlink. And they had their primary model as pushing data. Now, Linea doesn't have Chainlink, and Chainlink charges pretty large fees to deploy there. They're on Base. Now, Linea may be missing out on opportunities because there's a lot of DeFi protocols that are like, oh man, we're a fork of this protocol on layer 1 Ethereum that relied on Chainlink push oracle. And Linea may not have this yet, but Supra can provide this, and we're deploying. And these cost cuts make it more economical for us to push more data more frequently. This is why it's a big deal for us as well. Now, Supra is an interesting stack of multiple microservices. The Oracle problem is not just price feeds. It's cross-chain communication, it's randomness, and today, in its interoperability. Today, though, we're going to focus on data feeds as well as on-chain randomness, which can power fair gaming, unpredictable, unbiasable randomness. And for the computer scientists in the room, they know that that is a really interesting, deep topic. On-chain, deterministic but unpredictable randomness is a esoteric, interesting computer science problem. Now, what makes Supra interesting as a Oracle solution is that we apply layer 1 principles to shuffle and organize our network of nodes to create subcommittees called clans. These subcommittees perform different services in our network. Why is randomization important for the node operators themselves? For any, the analogy I like to give is a body of water, right? If it's stale, it's not flowing, like a set of node operators that are never changing, it will create a swamp. These node operators in different Oracle systems, they're in the same Slack community, they meet each other in person, they know exactly, they communicate multiple channels, they're colluding. Or at least they may be colluding, let's put it that way. But I have some interesting conversations in this regard. So what if we made it more difficult, virtually impossible, by randomly shuffling these committees often so that attack vector is mitigated, right? No one talks about this, but it's a big deal because there is something called Oracle extractable value if you're not careful. Now what we do is it's called commodity sharding. So different clans are going to be responsible for different assets. and every cycle, which might be every 5 or 10 minutes period, we aspire to randomize those nodes that are responsible for various assets. And this unpredictability is our security guarantee. You know, as long as our system remains at least a third plus one honest nodes, just like most BFT protocols, we secure our safety guarantees. And by the way, why does safety guarantee in Oracle matter? It's because all these smart contracts that use Oracle data, just so you all know, you reduce your smart contract security from the layer 1 to that of the data feed itself. Because a smart contract will do what it's fed. So you should provide layer 1 security to the Oracle, which hasn't actually been done. Moreover, we also shuffle the constitution of these clans. We try to randomize as much as we can. We have on-chain built-in randomization. So these extensions, these are some additional security approaches that we have been working on. So for example, if we know the price of Bitcoin to Ethereum, and we know the price of USDC to Ether, and as well as Bitcoin to, USDC to Bitcoin, we can actually cross-correlate these. And if they go beyond a certain range, we can trigger an alarm, because these should be within a range, if you can imagine, right? We also are working towards anomaly detection by basically creating what we call a historical consistency check powered by smart contracts. Long story short, we can kind of do on-chain, very, very simple version of machine learning, right? We look at the past. Remember, Super itself has an Oracle chain of the Oracle data itself. We can look at this and agree upon what is actually the historical, like let's say, values for the last 200 blocks. And if you get a result that is deviating, we'll still publish it, but we will flag it as potentially an issue. And the flag is up to you developers to decide, hey, we're going to use this or not. Maybe we'll pause our protocol for an hour, then we'll resume if you see a red flag. Now, why is that important? It's important because we do work with DEX data, and we have a unique approach to handle with decentralized exchange data, which traditionally has been a vector of attack through flash loans. This anomaly detection method through historical consistency check will give us the ability to kind of give developer the ability to, hey, red flag rarely happens. When it happens, we pause activity on our DEX for an hour. And the developer can set those parameters. They can say, we pause it for 10 minutes. It's up to you. So we aspire to build a very, very decentralized randomized network. We try to be highly efficient through the way the protocol works and resilient by applying layer 1 consensus principles to solve the Oracle problem. Okay. The next phase of the Oracle problem, remember we talked about, it's not just price feed data, it's cross-chain communication, it's automation, it's on-chain randomness. In fact, the Oracle problem is harder to solve than the layer 1 problem because there's so many different services you have to solve for. And in fact, if you look at Supra's website, supra.com/research, they're on the order of 8 to 10 protocols. We're going to focus on on-chain randomness. Randomness is important to power, games of chance, NFT attribution, loot boxes, many use cases actually. GameFi is a big use case. So on-chain poker, this is something actually we have a very good design for in a collaboration with Berkeley University. That will be coming out later this year. On-chain lotteries, if you do this kind of thing, you really want to make sure that there's no collusion. You want to make sure it's completely fair, because these things can only get and grow if there's trust. So unpredictable, cryptographically secure randomness is important for these types of things. NFT attribute generation, same thing. To make this fair, for people to feel like this was a fair draw, you want to have proof, cryptographic proof that this was done correctly. The key components you need to be looking for is unbiasability, unpredictability, and public verification. You want to make sure that, hey, look, no individual independent, node operator or agent or the DApp itself could predict the outcome, keep this truly fair, but at the same time, you want to make sure that anyone can verify this was generated correctly. We have a very interesting security guarantee, which is at least one single honest node has to be honest in the 51% threshold. Single honest node assumption. I'm going to try to keep this relatively brief. We're going to kind of jump into, how this works on the hood. Now, this basically relies on the secret key itself not being exposed. Now, ultimately, however, the issue is that these solutions and some of our competitors and some of these protocols themselves try to create their own randomness service. The issue, just kind of cut to the chase, is that it's basically a single party failure. Someone owns the entire secret key, and this is an issue. Now what we do is we distribute the secret key itself through DKG, distributed key generation. Okay, so Shamir's secure, key SVV, yeah. Okay, great. So effectively, there's no single party itself that has that secret key. We distribute it across multiple nodes. Our team is led by Dr. Annika Kate. Dr. Kate, by the way, is the person that created KZG commitments that enable, us to have 80 to 90% cost reduction that enables data availability sampling, right? KZG commitments. That K is Dr. Kate. He's also the author of a paper called DKG in the Wild, Distributed Key Generation in the Wild. And what we do is we perform a DKG ritual. We break the original key into multiple chunks, and we do this in a way that we leverage kind of hardened and great insights from the titans in the game. We're standing on the shoulders of titans, so Shamir's secret sharing protocol. We break it into multiple chunks, distribute them to multiple nodes, and we set a threshold of a certain amount of parties that have to participate in order to create the valid signature. What's really interesting that I want to emphasize is that as long as one single honest node is present in that threshold, the outcome is unpredictable by any party participating. So we are creating, this is actually a pretty simple protocol once you look at it, but it's this distributed VRF. And remember, our system is randomizing the nodes in the clans themselves. So every epoch to epoch, the participants are randomized. So you don't know who is actually going to be doing the service in the next cycle. So, kind of jumping into this, you take the kind of pieces of each of the keys, you put them together, you can verify this. The computation is actually very fast and cheap. And, ultimately, with these innovations, with, the changes in Ethereum right now, these costs are dropping. This is actually cheaper than verifying a ZK proof. A threshold signature, what this is a threshold signature is cheaper in terms of gas to verify than a ZK proof. We also have, models that, effectively allow us to use privacy-preserving randomness, which are interesting for example, on-chain randomness, poker. On-chain poker, where it's multiplayer. This is a very difficult issue to handle in a low latency, low gas environment. We do have a solution for this. You can read more about it on our website. But ultimately, what we're looking for in this distributed virtual verifiable random function is unpredictability, unbiasability, robustness, availability, and our solution handles these. We have been deployed on multiple ecosystems. Linea, we think, is very interesting in terms of its potential growth due to its coming from, consensus and MetaMask, and you can imagine how easy it would be to bring folks into this ecosystem compared to other layer 2s. The gas costs, that's a big one. From, remember, 0.2 cents per transaction to 0.3, it's actually a 50% difference. It's a big difference. So we're very bullish, and we, I also should mention that our team has decided that we are going to be providing Linea ecosystem a 10 million Super token grant. And we'll talk about the details, but those should be distributed to the developers. Yeah. Thank you, everyone.
Thank you, Joshua. I find it very interesting that you mentioned the threshold signature is going to become cheaper than verifying a CK proof. So next up, we have Stanley, head of research from MetaWeb Ventures, to talk about block building posts 4844.
Hey everyone, I'm Stanley. I'm the head of research at MetaWeb Ventures, and I also co-founded Linea protocol, not Linea, Linea protocol. It's the biggest liquid staking protocol on Linea blockchain. So yeah, today just gonna briefly talk about block building. After 4844, I don't know how many MEV searchers or even builders here. Hopefully it's gonna be an interesting topic. Yeah, so just a little recap on 4844 and so-called proto-dank sharding. So basically, like right now, layer 2s, they're uploading transaction data onto Ethereum layer 1 using call data. So it's a very expensive method because all data loaded through call data are like permanently stored by every Ethereum full node. So that's why it's super expensive. It's like above $1,000 per megabyte. So dank sharding is like the end game for Ethereum. So basically, like with dank sharding, they will do something called data sharding. Like they will just shard data, which means like every validator will only be required to like download part of the data, and they will use something called like data availability sampling stuff to trustlessly verify that collectively they have stored all the data. Like obviously that will make data storage on Ethereum much cheaper, and that will make Ethereum a more suitable like base layer as a data availability layer for layer 2s. But that's gonna take like years to build. So that's why like Vitalik and other guys they propose EIP 4844. It's called proto-dank sharding, meaning they are introducing the transaction format that's going to be used in dank sharding, but they're not really sharding the data, right? So they are only like introducing a new data, a new transaction format. It's called blob transaction. So they're basically sort of like opening up a separate space, in the consensus client, where it's like dedicated solely to data storage. And it's called like blob space, right? So adding roughly 0.75 megabytes per block. So after Dencun, layer 2s like Linea will be able to send transactional data, through blob transaction to blob space, which will be like much cheaper, in theory much cheaper than call data. But whether that will be the case, we'll see. So how much cheaper, right? So like this one is from like this screenshot I took it yesterday from Polymarket. So that's a prediction market. You can just literally bet on anything right on there. So right now, people are asking like, so what's the gas price per blob? So one blob meaning like one bunch of data submitted by by layer 2s onto layer 1, right? So today the cost is around 0.06 Ethereum per blob. Like one blob is around 125 KB. So obviously people are quite optimistic. Like we have like 33% of people who think it's gonna be below 0.0001 ETH. So it's gonna be a like 600x improvement on data availability cost, and that's gonna be like a huge reduction in transactional cost. That's gonna make one transaction on layer 2s like dirt cheap. I think like even Vitalik himself thinks it's kind of like too optimistic, too optimistic. Because the dynamic of I'll say, blob transaction, after Dencun, I'll say it's more complicated than we think, than it seems, on the surface. So, like, I don't know, if everyone here is familiar with PBS, with block building, with how blocks are actually constructed today, right? Like, basically, we have builders, who are specialized in constructing blocks, and like validators and proposers, they basically do nothing. I think like 90% of validators, they're doing nothing right now. They just collect, they just receive the highest bid from builders, and then they just accept that, the block built by that builder, and then just call it, a block, right? So like when we have, when block builders, are actually seeing like blob transactions after 4444, things will get interesting, right? So, here's some basic stats, for blob space. So we are gonna have like max 6 blobs per block, and the equilibrium, Ethereum Foundation want to achieve is 3 blobs per block. And right now we have many layer 2s, and in the future there will be more. And not like right now, like not every layer 2 is submitting like transactional data every block on layer 1. Like I don't know what's the frequency of Linea. I guess it's probably a couple minutes or even longer. Like for Arbitrum, it's probably a couple minutes. And blobs will have their own fee market, meaning they're kind of like in parallel with EVM transactions right now we see on layer 1. And yeah, like layer 2s can also like add tips to their blob transaction to for a higher chance for inclusion. Just like layer 1 users just add tips on their in your MetaMask for a higher chance of inclusion. So let's say when a builder see a lot of blob transactions sent to them after 444, like one interesting phenomenon just come up, which which is block propagation, because like blobs are big, like one blob is over 100 KB, and if you have and the more blocks you have, the bigger block you have, and basically builders, they have to participate in this continuous English auction through MEV-Boost. MEV-Boost is a relay which just hold this auction, and then they'll have to submit the highest bid to validators in order for their block to be included, right? To be chosen, as the next block. So, and the bigger your block is, the slower it propagates, through the relay. And for builders, latency is actually very important. Like the quicker, you can, update your bids, I'll say the bigger advantage you have. So if a builder, just like includes, I'll say many block transactions, in his block, that will make his block propagates like slower than other builders' block. Meaning this will, bring him a disadvantage, in terms of getting chosen, by validators. But of course, like, by including like blob transactions, they can collect more fees, right? Because, you do need to pay a fee, to submit data through blob transactions. So there's a trade-off. So slower propagation with blob transactions, meaning a disadvantage in winning the MEV-Boost or the PBS auction versus, higher fees by including blob transactions. And actually this, there can be a scenario where the competition between layer 2s gets so fierce that you just have to just attach a super high tip for your blob transaction to be included by builders. And that could be even like more expensive than call data, right? Because like who knows? So there will be I'll say a dynamic equilibrium, between blob space and maybe call data. But we'll see. Like nobody actually know, whether that will be the case. So, and this is all assumptions, right? I mean, they are all just hypotheses, and I like personally, I don't know, whether this will be the case after 444, but there are a lot of discussions around that. And so, is it really a big deal? So, this is a quote from Max Resnick. Actually, I think this guy is right now designing the data posting strategy for Linea. So I think he's the head of research at SMG, Special Mechanism Group something, and they're acquired by Consensus. And they're super professional in terms of MEV and all the stuff. So I met Max and I asked question, and Max said, I think layer 2s, are willing to accept, the risk. So a lot of concerns, but Max thinks, it's actually fine, right? Like layer 2s are rich, layer 2s are sophisticated, and data posting, it's not really a big deal for them. But I also talked to other layer 2s, and some of them, right, are interested in an idea called the blob futures, right? So let's say, what if you can buy blob space beforehand or in advance, right? What if you can buy one blob in the next, 100 blocks, right? What if you can buy futures, at least it's a very interesting idea, right? So the basic, framework is like, the layer 1 proposers will be able to make commitments, to layer 2s to say, hey, I promise that I will give you one blob in my slot, when I'm the proposer, and then the layer 2s, will just pay the proposer, money beforehand. It's just like buying a future, right? So in that way, layer 2s will be immune from gas fluctuation. They will be immune from this, I'll say, uncertainty, from competition with other layer 2s. Right? So I know there are projects actually trying to build this, but again it's very unclear, right? Like why? Like first of all, why do layer 1 proposers want this? Right now they're already getting the highest income they can get from Math Boost auction. So by selling futures, it's actually very unclear whether they will get a higher revenue from selling futures versus just remaining staying in the status quo, right? And the second problem is we are really not sure how, who and how to sell future block space. It makes sense for layer 1 proposers to sell, but they delegate block building to builders. So essentially you will be builders who sell block space, but then in that case you will need a commitment scheme for builders, and that will be like a whole different story, right? And then how to sell, right? You can probably sell. So right now, Ethereum proposers will know they're going to propose a slot, a block 1 epoch ahead, and 1 epoch is 32 slots, so that's like a couple minutes. So for a block future with certainty, the look ahead time, at most it's going to be like 6-7 minutes. Is that long enough? We don't know, right? So, and if it's not long enough for layer 2s and proposers to feel attractive, and then it's going to be meaningless, right? Again, this is all hypothesis, and I'm just super thrilled to see how this whole dynamic will play out after 444. But the final slide is forget about blob futures and all the stuff. So I want to just stress a bigger trend, in the space, which is block space commoditization. So in my opinion, the block space future is just one small part of this bigger trend, which is block space commoditization. So, in the beginning, a couple of years ago, Ethereum blockchain was super simple. It's just validators just constructing the block and then the propose and people attest, and then that's it, right? But with PBS, proposer builder separation, validators right now, most of them are not constructing their block. Instead, they're basically selling their blocks to builders, to whoever gives them the highest bid, right? So in my opinion, PBS is already commoditizing block space. And with with 4844, I think a new trend emerges. So block space, you can think of it as a more special demand for block space, right? It's not a general demand for block space. Blob or 4844 is like a a demand for block space, specifically from layer 2s to post data, right? So, and in the future, we'll get more diversified and sophisticated and specific demand for block space, right? So let's say from so-called intent solvers, right? I'm pretty sure some of you have heard the word intent, right? So like intent solvers, when they receive user intents, very vague intents, and then they're gonna solve them, cross-chain, they will want certain type of, I'll say, tradable block space. They probably want to buy block space before, in advance. And also we have arbitrageurs, right? So arbitrageurs are another group, of people who really want to have top of block, positions for their transactions. And right now they're just, they're searchers. They're just bidding to builders. But in the future, when Ethereum actually becomes a world computer, and when I don't know, 50% of human financial activities happen on Ethereum and layer 2s, we will have the most, the smartest HFT firms and Citadel, market making on there and arbitraging on there, and they will have more sophisticated models, evolving more advanced, statistical methods, which will make them actually want to maybe acquire some special sort of block space in advance, right? And then we have consumer protocols, right? They will need some very, very high frequency, but I'll say low value transaction, and they don't care about ordering. They only care about being included. So all sort of stuff, of course, including layer 2s, right? They will have very specific demand for block space, and this will prompt, I'll say, the development of block space commoditization. And so, with all that being said, block builders, right, they will still likely be the initial distributor of block space. They will still buy block space from validators, from proposers as a whole, and then they resell part of them to different parties, right? Actually, you can, there's a recent research topic called execution tickets. You can see it on ETH Research. Basically, it's a further commoditization of block space, and builders are actually buying, a whole block before it happens, right? But one thing is, right now, builders, they just specialize in ordering transactions. They build block, they order transactions in order to maximize their profit. So that's a very, very specific set of skills. But in the future, with block space commoditization, it's going to require a whole new set of skills. They will have to predict, the price and demand, for future block space. They will have to price, they'll have to accurately price every different parties, basically their price preference or their threshold, right, for certain type of block space. That's going to be, I would say, one of the most difficult, math and financial problem to solve, right? So, and let's see how, how 4444 will actually lead to this super sophisticated future, and we're going to have a lot of new builders, and we're going to have, the current builders actually, I'll say, transitioning super fast, into a new type of players in the space. And that's it, and that's my Twitter. So my DM is open. I'm a builder. I'm at the VC. So if you want to reach out, just shoot me a DM. Yeah, thank you.
Thank you, Stanley. So that's all the talks we have today. We have this space until around 9-ish. So feel free to network. There are non-alcoholic drinks and alcoholic drinks. If you got the approval QR code and haven't scanned your QR code yet, make sure you do that. There's 30 XP, Linea points, or 4 XP, whatever that's called, as well as a POAP. And later tonight on your way out, if you want to grab a few more t-shirts at the door, that's also fine. Good quality cotton tees. So enjoy the night. Thanks.